might be able to from the comfort of your home or your office if you're stuck there. And also, we're going to try to post more like virtual events. We're going to try things out, so please let us know if you have comments. Please put them on Meetup to let us know how everything is working out. So can we move on to the next slide?
Yeah.
Just want to make sure. So I did talk about Academy, which is, about the learning, which we all love. It's free online courses, Cassandra certification. There's a blog there. There's like short courses, long courses. It's just like probably, I don't even know if it's more like hours and hours and hours of content. So really go check it out and make sure that you just, get started on the learning side. And then we also have this new resource, which is DataStax community of datastax.com, which is all about bringing the community together around Cassandra, DataStax, open source topic, Spark Analytics. The conversation are a little bit all over the place, which is awesome. And we are bringing really people who have questions, and we want to bring also the people who have answers, and really collaborate together, and really making sure that everybody gets the most out of the community. So it's a great resource, so please join today. Again, free of charge, and basically one thing that is awesome as well is that you get to share your expertise. So we're going to be, checking out. There's going to be gamification. You will have a new MVP program, etc. So there's a lot of great things that are going to happen on DataStax community. And last but not least, I did mention that we're going to live stream through Twitch and also on YouTube. But check out @DataStax Devs because it's a great resource. We post a lot of different type of content that is developer focused. So it's a technical Twitch area and also Twitter area. So it's not about corporate marketing and all the fluff that, we just like, it's on something else that we don't want to talk about tonight. And so this is where you want to go. So DataStax Devs. And I think that's about it from me. Yes, you all moved to the front row. Nobody made it to the first, but that's okay. We'll talk about that later after the presentation. So I'll hand it over to Tom, and then enjoy your evening.
What about this slide? Be a speaker. Did you want to talk about that?
Oh, thank you. I forgot about the speaker. So we love people. We want to give the opportunity to people to share their expertise. And we know that there's a lot of fantastic use cases out there. So we want to make sure that if you have a use case, or if you want to talk about something cool you've been doing or something you've been trying out, etc., well, this is a platform where you can do it. And obviously, physically here, or obviously we can work also on online events. So if you want to grab that QR code, and if you're not sure about it, you can talk about it with me after the events, but we'd love for you to be a speaker at one of our future events. And then, there's these events, but we have larger events as well, and who knows, you might make it to our DataStax Accelerate, which is our customer event coming up in May. That was a bit marketing, but that's okay. So now it's over to you.
Okay, now on to the regularly scheduled program. Tonight, users group content. So it's sort of two parts. Hopefully it'll look very seamless and blend together nicely, but we're going to first go through a little bit about the DataStax and focus on Cassandra, what's new and interesting on that side. We also have a partner with us tonight. Knowi, who's going to really show, I would say, the power of leveraging the capability of the Cassandra database with their environment, and they'll have a very comprehensive demo to illustrate their tool set. So Jay will be, and Ryan will be presenting that a little bit later. And again, I'm Tom Luckenbach. I'm a solution engineer for the Bay Area. So as, again, hopefully get some interest in using the community tools to get connected. So I'll first walk through how many people are familiar with Cassandra and or DataStax. I mean, so everybody. Okay, so I'll just give you a quick, again, why is it interesting, compelling, and we'll try to, get to some of the interesting stuff. But we see a lot of recognition around the name Cassandra and what is DataStax. We are the commercial provider of the enterprise version of Cassandra with a lot of other layers and interesting aspects to it. But we see that this is, a small subset. You saw some of the logos on the wall of customers that are using DataStax. And the story is why are they using this? And the interesting thing is that, Cassandra's been around for over a decade. It's evolved quite a bit. And it's hard to believe that it has been around for a decade. I mean, when I think about NoSQL, it seems like, oh, that just came out last year, right? But this is extremely mature, and we're in this era now where we're less about having to prove the viability of what something like a NoSQL to do, but It's amazing what people are doing, where they've started on their journey to where they've taken it. And some of these examples are about, in retail and finance. Data era, a lot of the NoSQL technology was born in the big data era, but the ability to run retail sites at scale without outage, that's what drove a lot of the consumption. We needed technology that was just, truly unbreakable. I know Larry Ellison and his unbreakable didn't quite live up to the promise in some cases, but we see that the ability to run, scale, and handle the scale of retail and other applications in this space. So financial institutions running very large global databases for fraud, retail, customer experience around the world. Airlines, again, how do we track the users, your luggage and so on. Airlines are looking to this technology. So again, this is the profile, but we see that as early adopters, they harden this technology. Now we see this broadening out to a variety of other use cases. So, it doesn't have to be, you don't need to be petabytes to get in the game, starting with we need the need. And we'll talk through the profile of where Cassandra fits. Again, these are the poster child of Cassandra. Apple, hundreds of thousands of nodes for a variety of applications. Netflix, well known for their ability to deliver, at any point in the night, half of the internet's traffic is Netflix traffic or more, or something like that, or the statistics. What is it, Chuck? At least that, right? Something. He's always telling me that statistic, but I can remember the detail. But these are, again, huge consumers that have helped harden and develop this technology. Where we're moving is, most of these are, again, private cloud, on-premise solutions, but now the ability to move to public cloud is a popular trend. And it turns out that we are ideally suited for these environments. This migration to cloud, given the architectural advantages, and we'll touch on that briefly. But Cassandra as a service is something we're working on, and I'll get to that a little bit later. But this is, again, allowing opportunities to increase velocity on development, spinning up clusters very quickly, and providing a richer set of tools to build out new and interesting applications. We've given it a new name. It is called Apollo. So rather than Cassandra as a service, you might hear the name Capallo, and that's our fully managed implementation. It's in beta at a variety of public cloud providers, so we're excited about that. Again, the origins. We stole or homaged some of the cool things that Google was doing a decade ago and with Dynamo, and this became the foundations of Cassandra. So we leveraged the underpinnings of these leaders a decade ago to create Cassandra. And again, this is the key features that we see. Masterless distributed architecture. That's the foundation of this resiliency, the ability to scale out and never go down. Fault tolerance and high availability. Everybody talks about it, but being able to live up to that, improve it time and time again, the ability to we hear companies like Macy say, our database has never been down for 5 years. You go, and you say that to some people, and they're like, really? How can that be? That's the nature of this beast. Scalable. We could think about how we scale databases. Well, you could double CPUs and maybe add more processors, and you could maybe grow by, I could double or triple my performance capability, but that's small compared to the way we scale out in a horizontal scaling approach, to be able to go from a cluster that can scale out 100 times or 1,000 times and linearly provide that capability, whether it's on a single location or on a global basis. And that leads us into, again, the multi-location, multi-DC, or multi-cloud, or intercloud, or all the hybrid architectures that we can think of, being able to create a database, a single database where data is consistent across the globe. And then breaking away from this idea of a master-slave, or that's common, this 1-to-2 relationship, the ability to have 10 different sites all managing the same data in real time is really compelling. And we found that, the profile of our customers of, leveraging these features, we're looking for these ideas of we want to build a real-time, contextual, always-on, distributed, scalable database. And this is this profile that we look for. And we don't need to have a match on every one of these, but this is where we found that where Cassandra fits, it's about this always-on, real-time, distributed, scalable, and to build out contextual applications that we can see around search, analytics, providing interesting dynamics to our data for websites that power the industries. Turns out we were, I guess, a little bit ahead of the cloud, but it turns out the architecture was well suited for the cloud. The ability to just extend a data center, whether you call it a data center or an instance in the cloud, and grow that seamlessly. This hub and spoke model, hybrid model, gives us a lot of power to deploy and extend. This linear scalability, I talked about it a little bit, but this is something that's hard to conceive when we think about most characteristics. We think about diminishing returns, whereas Cassandra, you double the nodes, it's truly double the performance. It's quite fascinating. All right, so this is again all the reasons why we know and love Cassandra, but from a DataStax standpoint, we've gone a lot further, providing tools. So DataStax Studio, it's a notebook to allow us to take advantage of the languages. So leveraging SQL, not SQL, but CQL. And so what is CQL? It's a familiar, SQL looking like language, but it provides the way, the interface to access our data in Cassandra. Studio supports Graph. It supports Spark SQL, so we can very easily move from one context to another and build applications, prototype them out in our notebook, and then build compelling applications in any language, any relevant language, given the wealth of drivers for all the popular coding languages. The Studio, I mentioned that. Again, we're seeing a lot of interesting evolutions in our graph database as well. We'll have some announcements in that area, but being able to visualize the relationships within a notebook is pretty cool. I can show that in a bit. But what we're spending a lot of time at DataStax lately is focused on this new thing called Constellation. Again, how do we bring the simplicity to a wider audience? Being able to deploy what is, platform as a service or Cassandra as a service, database as a service is one of the facets. We're extending some of the areas that we've, with a product called Insights. So this is a tool that picks up where Ops Center, which was our management interface for monitoring, but also giving us more performance characterization. How is the database performing, rather than is it alive or dead, or typical ops reactions. We can start to do more proactive characterization with Insights, and more to come. And one of the more to come is something called AppStax, and this is a tool to help accelerate application building. It has some elements of data modeling, but it's designed to help build and deploy an API for your application, which is pretty cool. And I will, instead of looking at the slides, I'm going to do a quick demo of that. And this is kind of interesting. So AppStax, this is in beta right now. I think it's in beta. Is it, Chuck, in beta? Can we get to it on Constellation, right? So you log in to a Constellation, and we get this little interface. I'll pick the e-commerce demo. And one of the things that is striking right out of the gate is to see an ER diagram that looks more like what you might have seen in the relational database world, in terms of things like primary key connecting. So we've realized that so many people come from the relational world, we decided to, model this tool in a more friendly, I would say, approachable manner people are used to understanding. If I build my tables with this ER mindset, and then I can adapt it for the nuances that Cassandra has around primary key, rather than, say, the foreign key concepts of a relational database, we can start to build out a data model, and as helping with some of the guardrails to prototype an application. So I go into this, and we see that there are areas. First of all, we want to build, what does the data look like? We can look at then how do we get data in this change events. We can then develop some of the queries, and finally look at the deployment. So this is, again, the complete sort of life cycle of building an application, model it, and deploy it. And now we have a quick way to build out an application RESTful interface. So we go through, we can modify, the tables accordingly. So not that zip code is a date time, but I'm just sort of illustrating that we can, what this interface looks like. We go into the data change, which is again about how do we get data in. So I can model some either updates, upserts, deletes, and so on. What does this look like in terms of the profiling of the data? Is it going to be real time? And we want to talk about consistency levels. What does this look like in terms of the data being pumped into the database? How do we access the data? We can build some queries. I like this one, high dollar orders with customers, so I can start to model some of the queries. And this is, again, aligns with the approach of query-driven table design. So we can now see that we've hopefully built tables that are suitable for the queries that we have in mind. And I can, again, model this according to what I expect the results to look like in terms of response time and or consistency. And finally, I get to, some of the deployment, and I can then build out this will build out what would be the RESTful endpoints to provide the interface for these queries that I've already designed. Launch this in, say, Swagger. You can see what the details of the RESTful interface is going to look like. We've now simplified a lot of the aspects around, not only just some of the data modeling, but now how do I ultimately connect this to an application? Again, Studio, talked about that in a simple way to develop and test an application. So this notebook is going to show some of the power, it gives us the power to decide we want to leverage the SQL language and build some queries on SQL, or if I want to leverage Spark SQL, so I can build out a bunch of queries and test them against my database in this notebook, and validate that I have, again, some of the coding right, or and get a feel for the performance, and test out the various approaches. So again, things like that I can't do in SQL, joins and aggregates, I can start to model these in Spark SQL, which gives me some options in terms of deployment strategy. So I wanted to, again, just to hit a few of the highlights in terms of where we're going with some of the new developments at DataStax, database as a service, development tools going beyond just drivers and some of the connectors that we've had out for quite a while, but tools to help us with application deployment and shifting into, I would say, the era of data management, providing simplicity and agility, deploying these in a cloud-based environment to quickly spin up an instance and either fail or move on with a proven model. So with that, I think we I could take some questions, or we can then shift over to the other side of the presentation tonight, focusing on Knowi's application, which is all about bringing data to life. How do we analyze and visualize the data that we might have stored in Cassandra, for example?
No questions? Do you mind firing that up into slideshow mode, please?
Yep.
Thank you.
Sure.
Awesome. Can you hear me back there? Perfect. Hi, everyone. So I'm Ryan from Knowi. You've heard a wonderful story about what DataStax does. Most of you are either consumers of DataStax today in some form or other, maybe reselling, maybe the technology stack or whatever else. We have a fantastic partnership with the DataStax team and with the organization, which we're going to talk about as we move along here. But most importantly, so Knowi is an end-to-end analytics platform that instantly connects to your DataStax data anywhere of any size, allowing you to make data-driven decisions. Now, there's some simple words, real short, simple words, but they are rather powerful. When we talk about DataStax data, Cassandra, DataStax Enterprise, and now with our native and instant integration into Constellation. When we talk about anywhere, we don't mind where your data actually is. On-prem, in the cloud, onshore, offshore, not a problem for us. As long as we have the ability to see it, we can connect to it. Size for us is actually not a problem. Small, medium, large, extra large, big data, whale of data, whatever it is, really not a problem for us. And why that comes into play is because of something really important for what we do as a platform. We eliminate the requirement for ETL. No data conversion, no data flattening, no data movement, which traditionally takes a long period of time from once you've connected to your data source, you do all this modification and conversion and whatever else goes along with it, until you can actually get to see some results, some value, some visualizations from your data. Takes weeks traditionally. So we remove that whole requirement. Most important for me, most important for us as an organization, as Knowi, is you. Our biggest goal is to put the power of your data in your hands. And the you could be anyone in your organization, anyone that needs to see their data how they want it, where they want it, and when they want it. What we're going to jump into in a couple of seconds is actually we're going to show you a demo, a run-through of what the Knowi platform actually looks like. And Jay will go through a number of key integration points that we have with DataStax. The fact that we have native integration. We talk the same language. You don't have to learn a new query language. We actually talk in CQL. We eliminate ETL, as I've already mentioned. We provide natural language processing, the ability to provide Google-like search functionality across your data, across any data sources that you actually have. And lastly, very similarly to what DataStax does, is we actually provide flexible deployment model. We can provide an on-prem solution, depending on if you need that or not, in the cloud as a SaaS-based platform. And we also provide the ability to OEM or white label or embed our platform into any solution set that you're actually developing. So with that said, I'm going to hand off to Jay, who's going to run through a number of, probably a small handful of slides and dive deeply into our technology. Do you want me to click over for you?
I think I'll do a couple of slides on here and then
Perfect.
switch over. All right, got the mic on now, by the way. This out of the way. So let me start maybe first about how the company came about, and then we'll get into the demo. So a few years ago, 4 or 5 years ago, I used to run product at a company where we had 19 different silos on data in SQL databases. We had data in Cassandra. We had data across REST APIs and so on and so forth. And what we were trying to do was build this analytics portal that's built into the application that our customers could use. And looking at things in the marketplace, it was just a little bit of a disaster because you had to put together ETL teams, you got to bring data from structured, unstructured, semi-structured data into a relational store, move that into some sort of a data warehouse, then have your old school BI tools that were built for 2000s to bring it to life. So the genesis of the company was how do you as an organization get to insights very quickly? So giving you that agility in your data that helps you make that decisions and things like visualizations and dashboards and sharing it with other people very quickly, as well as the more advanced things. So there's a couple of things happening. The enterprise architecture has been changing for the last decade or so, right? So you have a combination of not just SQL databases, but for when you're talking about high volume data coming in through Cassandra or Tom, I think might need your help on that one. And you have structured data in SQL databases. You have data across REST APIs and so on. So what Knowi provides is this is first of all a data services layer or data as a service layer that helps you get to Cassandra data, mash that up with SQL data along with your other data, wherever that might be, across data centers and so on, and have these ability to do transformations on the fly. You can do a data discovery, multi-source joins, and also on top of this data as a service layer, then we have natural language processing, which means Google search queries on top of your data that you've exposed to your end users. So in a case like if you have data in Cassandra, one of the demo use cases we look at is querying Cassandra, querying something else, being able to do Google search like queries on top of that data to get to insights very quickly and also embed and share and so on. So that's what Knowi's value proposition is. It's almost like think of how analytics has been evolving and where it's going. And where it's going is this concept of being able to get to the data very quickly instead of having to be shoehorned into ETL processes and so on, and also having non-technical users get access to that data and analyze it and act on it very quickly. With that, I'm going to do a little bit of finagling here and then move it to my computer and then go through a demo. I'm going to sit down instead of just crouching over in a second. All right, and I'll move that over. So first up, connecting to data sources. So we connect to a bunch of databases. I have some connections set up here. We got some data from Tom around some transaction data. We loaded up that into a Cassandra database. So it's a DS bank key space that we have some data in Cassandra on. And what we'll do next is use that to basically drive some queries against it. So the first thing we do is we natively discover what's in it. So in this case, there's a couple of tables. We're interested in transactions. And from there, you can start writing SQL queries against that directly. So it's completely native SQL. There's no ODBC drivers or JDBC drivers you have to install, anything like that. We spent, the foundation of Knowi is that native integration of using NoSQL databases for a reason. So it's how do you expose the power of that natively up, right? So that includes things like, being able to do what is the primary key, what's the partition key, what's a cluster key, what's a secondary index along those along the databases that you have, or the tables that you have. So from this transaction table, for example, if I'm interested in things with the location of certain kind, we can then basically either generate the CQR directly, or you can type that into the query editor as well. So in this case, if I'm interested in transactions in Dallas, for instance, you have that CQR query on the right-hand side. That I can execute, and it will go against Cassandra to give you the data back. And then what it allows you to do is you have strategies on how you want to manipulate or store this data model, so to speak. So in this case, you have tags that is basically a set in Cassandra. I think this is JSON type, and so you have a couple other types. So we detect these types natively too. So coming back to that native integration piece, that's important in the sense that you don't have to unnest stuff, or you don't have to relationalize the data. You can keep it in the natural form that you've chosen the database for. So let's say then I want to, Cassandra doesn't support joins natively, so but Knowi allows you to do joins within databases where the databases don't support joins, or you can also do across data sources too. And it doesn't have to be Cassandra, it can be Cassandra in one data center, and it could be an API from somewhere else, it could be a SQL database from somewhere else as well. So in this case, I'm just going to join this with another table in Cassandra, which includes the merchant information and the categories. So the merchant category includes a category for each of those transactions that we saw on the transactions. And then you can basically put a join clause together that helps them tie the two things together. And then the resulting data set would have the category information as well as as appended to the original transaction data set too. So do a quick preview on that. And while it's working away, the next step I'll do is also join this with a REST API, which is a completely separate API that you want to grab the population information for data for each of the cities that this data set has. So if you notice on the right-hand side, you got the category, which is coming from a separate Cassandra table. So let me also do the API. So this API basically gets us the city information from some public API information under records. So the records collection itself, or the nested hierarchy, has a bunch of things that we want to get through, and we provide like a SQL-like syntax to be able to parse that data as well. So I'm just going to do this very quickly. So I'm just going to do records, select fields. And this will make more sense once I go through the rest of it. Let's just make sure I got this right. So I'm basically hitting that API endpoint and grabbing some data. I've got a typo here, do that. Let's see if I've got this right now. So we get the population information and geographical information from some API. Then we're going to mash that up with data from the two Cassandra queries above. So you're going to do an inner join on location, which is the field, one of the Cassandra fields above. And I've got a city that's coming from here. And then the resulting data set will have all the information that we need across these two multiple data sources. And from there, the next step is, this is more on the way our product is architectured is, you have a data engineering side, which is people who know what they're doing with where the data is, what is it that you want to expose. You typically don't want your end business user to go directly into Cassandra, right? So this abstraction layer helps you determine what it is that you want to expose that the business user can interact with and go to town with. And what we have options for, this can be either real time against the database, or it could be we can asynchronously run this, cache it, and then the users are hitting that cached view essentially that's periodically updated, even on large data sets. So from this, and this is almost a segue into NLP, but I'll just, on this, we don't want some of these fields. So if I'm just interested in grabbing a few of these, I want to get the population, category, latitude, see, so then, you know, I just want to grab some of these fields from it. Merchant, city, let's keep one of the tags as a nested element and see what we get. And also, we want to do some manipulation on the amount, so we can add some sort of function. So we've got this data set that we can basically expose to our business users, essentially. So just to recap, we connected into Cassandra, we connected into 2 different tables, joined across Cassandra tables. Then this is without user Spark and so on, right? So this is almost a lightweight way to join up things within Cassandra, as well as then we use an API to also join that data from Cassandra. And this data is ready for a non-technical user to basically go build their stuff from. Anything else I'm missing? Let's see. Yeah, looks good to me. So let's save this, give it a name. Actually, I might have to change one thing. I'm just going to take this Dallas thing off so we get data across all locations. Take the limit off too. Give it a save and run. Just let it do its thing. And this would post up shortly when it's completed. Well, so while it's doing that, I'm just going to create a new dashboard. And now imagine you're a business user and you don't know how the data has been set up, and you want to basically bring this, you know, to what you were saying earlier about bringing this data to life. So we got this data set that looks like this. It detected geolocation, so it's going to put a geolocation visualization together. Let's say I want to change that up to slightly. So now we know where the transactions are happening, so mostly concentrated around Florida, for instance. And then you can drill into each of those locations more if you want. But if I want to do some more analysis on that data, so let's say I want to ask you some questions. Call it what is the average or total amount. Let's just do total amount. So you can ask questions against it and we'll figure it out what your intent is. So by category, for example. And you know, these are the amounts by categories from that data set. I want to put that into some sort of visualization. There's about 35 different options. You can go and customize it any which way you want. Let's say I want to clone this as. I'm going to create a few visualizations of that. So you're basically asking questions without knowing the answers from that data set that you pull together from different sources, essentially, right? So that first of all, we give you that agility in terms of data from across different places, including Cassandra. And now it's really interacting with that data without knowing the details and the particulars of how it's all put together. A few more. Let's take something a little bit more. What's the average amount by city, by category? Put that into maybe a stack column of some kind, city and category. Go another one, and one more to boot off, but to finish this NLP segment off. Let's say we want to know something a little bit more complicated. Oh, you know what? I actually forgot to put the transaction time in there, which is fine. We're going to go back into the query and just add that in as a field that me as a business user want to use. So I'm going to go into the query and say hit preview. Let's just see what we get, and then we just need to add that transaction time into into the data set. Okay, so transaction times to be added. So we just modify that result that we from the queries that we were putting together earlier, and just let it finish up. So this will tell you how long that join across them has taken, and then in this case, I've directed it to cache the data, but you can make that real time against Cassandra or other sources too. Okay, we're good to go, and then the last thing I wanted to do here was take one of these and just ask it a more complicated question, which is, what is the, call it median amount in June for Dallas, let's try that. Okay, median amount for Dallas across all times in June 2 years ago, maybe something like that. And that would tell you that for Dallas it was $638 in that transaction. All that coming from the original data set from the transaction data set that Tom gave us yesterday, I think yesterday or the day before. Maybe a quick change by city. Let's do that. So you just get a visualization of all of them. Put that into a donut chart maybe. And then you can do things that drill downs on top of that data. So if I'm interested in Birmingham, for example, and how the data is correlated to just that city, you can set up drill downs into it. Say, let's see, city, right? So I click on this guy for Birmingham, and then you just get to see Birmingham data. So it's that whole process from wherever that data might be all the way to your visual insights, and then you can take this, embed this any which way you want. The NLP side you saw, what we just came out with also is to take that and be able to embed that in any of your applications, so it gives you that Google-like search capabilities on data for your users too, for when you need it. Any questions on this? And if not, I'll just go into a machine learning side too, if you have enough time, and then wrap up. All right, so let me jump into machine learning. So where the ML side fits into the picture is you can create models within Knowi. We can create models in other places, like SageMaker and so on. And then you can apply that on top of results from your Cassandra database or other places. So in the flow I just did, for example, that's connecting to multiple different sources. So on the ML, if you do decide to do things within Knowi, there are a few ML type use cases that we support. One is classification, which is this customer likely to churn? What's segmentation? Is this customer, is this cancer cell or not? Those types of use cases. Then you have regression, which is predicting a set of numbers based on some attributes. Both of those are trained, supervised learning examples. So you need training data to feed it to build a model. And then the last one is anomaly detection, which is unsupervised learning, where you can have time series data that you can basically detect anomalies and trigger alerts and things on. So I'll take a quick example on classification, just do a walkthrough on that. So it starts off with a training data set. So I think I have one here. So I've got a data set that I've uploaded earlier. Cloud9QR is a SQLite syntax that we've developed to do some transformations on the fly. So I'm interested in getting all just limited by 10,000. The attribute that I'm using that I want to predict is a payment flag, which is on this data set is who are the folks that have historically defaulted, and what were their attributes that might be correlated to them defaulting essentially. So if you look at a data set, you get a bunch of things right at the end. That one indicates whether this person defaulted. So this this entry defaulted, and this is the associated set of attributes for that. So what's a credit limit, what's a education level, are they married, so on and so forth. And then we'll ask you a bunch of questions, data science type questions, to basically help you build a model. So let's go through that. So data types, I'm just going to skip through most of these. Flag any outliers, missing values, any more data science questions about normalization, standardization, if you're familiar with those type of concepts. The most important part is the feature selection. Now you can either we can run through the algorithms to figure out which ones are correlated to each other, or since I know this data set quite well, this might take a little bit of time to do. So I'm just going to select all of them except for the ID. And then you can run this past a number of algorithms and figure out which is the best fit. So while this is training, what we should see shortly is the results of this correlation to say how, if you look at this, the decision tree and logistic regression are the highest scoring algorithms that we could find, right? These two, not so much. So it's probably, we'll just select one of these and then just plonk it in there. One thing we're also actively working on is our Python integration, where you can create these models directly into Knowi as well. But that's a quarter or two away. And then you can basically save this as a model that you can deploy for incoming data, right? So call it DataStax model. I'm publishing this, and then you can use that against data in Cassandra that you want to query against, or it could be Cassandra plus other sources as well. So let's say I've got Cassandra. I think we have a incoming data within Cassandra called credit card clients, which actually does not have that likelihood of that person defaulting. Right, so if you look at that, if you just execute a simple CQL query on this, we'll get the results. We should get the results without that payment flag, essentially. But then you can just apply the model, and then we'll combine the two together and tell you which ones are likely to default. So that's the one I just created. Hit preview. And you'll see a new field called predicted payment. And then if I'm just interested in the ones that are likely to default, set that to be the case. And then you have this data set that you can use for not just for visualizations, but also for downstream processing, where if you want to send this data set to customer care via a webhook, you can do that. Or you can send it by Slack, for example. So internally what we do is tickets that we get from customers, we use something like this to basically then trigger out our response through Slack as well. So that's that to tie this all up. It's this where the ML fits into our picture is the ability to do predictive things on your data that's incoming that is either done in Knowi or outside of Knowi, that combines and gives you the hindsight plus foresights, and then it allows you to take action from that. Any questions? I think that's the general gist of what I want to talk about.
If you look at a table like this, would you be able to tell why certain things that taking this particular example, if I said, why is the third row considered a defaulter? Asking questions about specific things to be able to explain what the model is, right? How would I go about that?
That would be, you wouldn't do that necessarily at this level. You would do it when you're creating the model. And right when you're creating the model, so let me just save this. So this will allow you to basically inspect what it's done when you ran the model and flag you which ones. I think, let's see. I think there's if you do that. See, when you look at that predicted thing on the side, when you do the training, it will tell you which ones it failed and which ones it was successful. So those two columns at the very end, you can see that, you know, some of these cases, especially early on in the model running, that it got this wrong, right? So how it exactly figured that it got it wrong, it doesn't really tell you that, but you can infer that if you're familiar with all the attributes for that model and change it up. You know, so there's a whole bunch of settings you can tweak as you're doing iterative development on it. If you're doing linear regression, for example, how many iterations do you want to go through and do it? What's the tolerance level and so on? And that might be different for another algorithm. Any other questions? Thank you, guys. Appreciate it.
I can do the prize and then you can wrap it up if you want. Okay, so I did promise a brave one, so let's sit in the first row. So if you can look on the left side of the chair to see if you have a little sticker. Yay, you do. Did you get the Cassandra? I know. And you have one too. Oh, that's the two each. Awesome. Okay.
Totally.
Well, you know, if you don't want it, you can gift it to anyone. Christmas is coming. And it's actually an awesome book. It was co-written by one of our developer advocate, Jeffrey Carpenter. He's working on the next edition of it, but it's deep dive into Cassandra. Everything you ever wanted to know about it is in there. So it's actually an awesome book. Okay, so I also promised we have a small crowd, but I'm still going to do the drawing because that's the way we decided to do it. So we have 5 of the vouchers for the certification. If you don't want to use it for yourself, you can always gift it. I think that a lot of people will be appreciative of this, so I'm going to choose 5. And I don't have my glasses, so I'm not even seeing who I'm choosing. So there you go. Okay, so Chandra, are you still here? No, Chandra. If you're not here, you're not going to win. So Shirley, is Shirley here? Awesome. Okay, so Shirley, I'm going to meet you at the end. And make sure that at the end I'll meet you. Make sure I can read your email address so we can. Okay, so Kanan, yeah, Kanan, awesome. Checking that everybody's Ken Lee. Yeah, awesome. And then I'll do another one. Fu, awesome. And then okay, let's do this one. Raj, yay. Okay, awesome. Okay, so I'll just double check with you that can read your email address, and then we'll take it from there to get your vouchers. Okay, I will let you guys wrap it up.
Perfect, thank you. Thanks, Christine. So before we do wrap up, we know everybody here loves some free stuff. We've seen that because I can see the big smiles on everybody's face that just got a book or whatever else. We also like free stuff. So please do go to knowi.com/free-trial, log in. We'll actually challenge you because we talk about the 32-1, which is it'll take you 30 seconds to sign up. It should take you 2 minutes to connect your data source and approximately a minute before you get your first visualization. So go test drive our platform, log in. We won't hassle you about it, but would love to see as many people as possible from today or live stream or whatever else signing up. With that, I'll hand over to you, Tom.
And one more thing, all the things I was doing there, that's if you hit that Cassandra or DataStax icon, it's pre-filled with that data too. So you don't have to go in and connect your own database unless you want to.
The data from tonight?
Yeah, data from tonight.
Perfect. So if you did or did not hear that, so the data that Jay demoed this evening, was bank data, financial data, credit card data, whatever it was, that is actually preloaded for you. So if you do jump on, sign up, test out the trial, you'll be able to have access to the exact same data that he was demoing tonight. Thank you. Over to you, Tom.
I'm only going to say this is a testimony. So we knew about this meetup for a while, but in terms of pulling this together, I gave him the data set on Monday because we wanted to have a real live data set and not just be this cooking show thing that it's fake. So the point is that the ability to take a data set, this was a transactional data set, a real data set that was in the Cassandra database that we used to show fraud analysis using, say, Spark and whatnot. But he was able to take this database, load it, and actually then make sense of it using his tools without knowing anything about it. All I did was say, let's use this transactional data set. So again, to me, that was a great testimony to illustrate how you can bring your data to life with an application like Knowi, and again, the compelling reasons why people use Cassandra to store large amounts of data, and then now, how do we make sense of this data? That was this, we're in the era of, going beyond just collecting data. We need to understand it to make sense of the information and make meaningful decisions. So I thought it was, this came together amazingly well in terms of what we wanted to do with this user group meeting. And again, we'll look to do other themes down the road. And again, we're launching our Constellation offerings. So we can, again, I urge you to take a look at our website and take a look at whether it's on GCP or Azure, AWS, and soon to come on Azure, our Constellation offering to rapidly develop applications using Apollo, AppStax, and the other tool sets that will be coming out. So again, thanks a lot for coming, and I guess we kind of call it a wrap.